that, I think I'm gonna let Naomi take this away. We have Naomi Akwat here, who's a glacier scientist. She studies ice, and she's gonna be talking to us all about ice today. So take it away, Naomi.
Hello, I'm Naomi. I am a research assistant at Ceres and with Clean. And today we're going to learn all about ice. So to begin, we're going to have some poll questions for you. So take a second to check out the poll and see what we have. So the first question is, what is ice? What is it? Is it a solid? Is it cold? Is it hot? What do you think it is? Take a second to answer the poll. Is it frozen water? Is it part of the earth? Is it separate from the earth? Does everyone have access to the poll? If you don't, go to menti.com and use the code at the top of the screen. Just type in the number and then you should be able to click on the answer. If you have questions, Alicia can answer them in the chat. Great, we have some answers coming in now. So this is just to get you thinking about ice before we really start with our experiment. Okay, now let's go with the next question. What causes ice to melt? Is it the sun? Is it warmth from your hand? Is it the tiny bonds inside of the ice breaking apart? Is it all of the above? Just to know what you think. What do you think causes the ice to melt? Now that you've thought about that a little bit, what do you think causes that? What do you think happens when you go outside in a dark t-shirt versus a white t-shirt? If I have this shirt on and it's kind of dark, it's purple, but what if I was wearing something that was more white? What would you experience? Would you be warmer in this, or would you be warmer in something like this? And think about why that is. Like what causes that? We'll get to that later on in the experiment, but we just want to get you thinking about the different things that can affect ice and the way it melts and interacts with the earth. Great, so the next thing is our actual experiment today. So if hopefully you have had a minute to get some of your materials. If not, we're going to put the material slide back on and give you a second to gather two glasses, hopefully clear. If they're not clear, that's okay. Definitely need at least 4 cubes of ice and some plates. We have a light plate and a dark plate, and a ruler would be great if you have one. If not, that's okay. We also would like some thermometers, but I have thermometers, so if you don't have thermometers, that's okay too. But take a second to gather your materials, and we'll just leave this list on for a second. And make sure when you're getting your materials that you keep them away from your laptop. stops because we're going to be melting ice, right? So we don't want that near the computers because water and computers don't match very well. Okay, so today we're going to be scientists. Here at Ceres, we work with a lot of scientists, hundreds of scientists who study ice, including myself. I study ice in the Arctic using photos from satellites and some field data to see how the ice changes. And today we're going to see how the ice changes right here in our houses. So we have two experiments today. We have our plate experiment and we have our glass experiment. So please take a minute to take your glasses and fill one up with warm water. Doesn't have to be hot, just warm. And then one up with normal tap water, lukewarm, kind of cold if you want. You can experiment and decide for yourself. So we're going to see what happens to the ice in these different environments and how they compare to one another. And you might be wondering, well, why would we do that? So we want to do that because the climate is warming and the ice is melting, and we want to see how these different environments cause that to happen and what they do. And that's because we have a lot of ice on Earth. We have ice in the north up here, and we have ice in the south here. We also have some ice in the mid latitudes, like in the Himalayas. But today we're going to focus on the Arctic, even though there is a lot of ice in the Antarctic. The Arctic has a lot of sea ice, as well as land glaciers, so land ice. And we're going to be exploring those differences. So we have our land ice, which will be our ice cubes. We also will have our sea ice, which will also be ice cubes, but they'll be going in the water. So hopefully everyone has all their materials now, and we're gonna just set this up. So I'm gonna put one ice cube on the plate and another ice cube on the other plate. I grabbed two ice cubes that are about the same size, and I laid them both on the same side because on one side, I don't know if you can see that, it's kind of thin, and on the other side, it's a little bit thicker. So we want the same side on both plates down on the plates. And then I'm going to take two more ice cubes that are about the same, they look about the same size, and put one in the warm water and one in the cold water. So give you a second to do that. And while you're doing that, I have some boards to write down what is going on with the data. First, now that I have the water in, or the ice in the water, I'm going to measure the height of the water because this is the sea ice, right? And it's part of the ocean, and I want to see what the height is of the sea level. And for the warm water, I have 11.5 centimeters. So I'm just going to write that down for warm, 0.5 centimeters at beginning. And then for the cold water, it is at 11.1. So I have written that down on the board. And then I'm also going to write down the temperature. So the temperature equals, in the warm water, ooh, it is quite warm. In fact, it is so warm that the ice is already melted. So I'm going to just put another ice cube in now and re-measure the ruler. But the temperature is 110 degrees Fahrenheit. And the temperature for the cold water is 64 degrees Fahrenheit. And I'm going to remeasure with the ruler for the warm water and see what happens. Maybe your ice is also already melted. It has increased because I put ice cube in it, and now it is at 11.9. back to our plates. So what I'm going to do is I'm going to put these on the porch outside to see what happens in the sun because they're different colors. Remember, we were thinking about our t-shirts and how that felt when we are standing in the sun in our dark and light colored t-shirts. So I'm just going to go outside. Put these in the sun. And we'll let the plates sit there for a while. So we'll come back to them in a little bit. And now that we have our experiment set up, we're going to make some predictions. One more thing is I want to measure the air temperature. So for outside, the air temperature is 63 degrees Fahrenheit here in Boulder, Colorado. And inside, the air temperature is 72.5 degrees Fahrenheit. And I wrote that on the plates just so that we can compare those temperatures. So what do you think is going to happen to the ice in the cold water versus the warm water? I think you might already know, or I already know looking at the warm water. But which do you think is going to melt faster? Do you think it's going to be the warm water or the cold water? And then the next thing is, what do you think is going to raise the water level in the glass? As it melts, is it going to raise the water level? We have our initial measurements, so we'll be able to test this as the experiment goes on. Yes, everyone says yes. Oh, there's a few people saying no. Oh, it's tied. Oh, we'll just have to see. Luckily, we will find out by the end of this lesson. You will know the answer. And then the next question is about the plates. So we set out our experiment there. What do you think is going to happen to the ice on the light plate? What do you think is going to happen on the dark plate? How will they compare? Will the ice melt faster on the dark plate or the light plate? Why do you think? Maybe start thinking about why that could happen for each thing. And then what do you think the ice on the plate is going to melt when compared to the ice in the water? Is it going to melt faster? Slower? Why do you think it is? What causes those things to happen? Like, what do you think is happening? And now the question is, and we're going to actually hear from you now, is what observations are you going to make to test these things? Are you going to look at the water level changes? Are you going to look at this is a thermometer, you're going to look at the temperature changes? Are you going to draw your ice cube and see how that drawing changes over time? Maybe this is disappeared. So just take a second and think about what observations you're going to make. I'm going to use my ruler and measure the changes over there. When I look at the plates, I'm going to see how much water is on the plate. Yeah.
And if you would like to speak up, you can just raise your hand and I can unmute you so you can speak instead of writing something in the chat. So what observations will you make? We have one person saying it depends on the air and water temperatures.
Great. So now let's look. Let's go visit our glasses and see what has happened. So what do you notice? Let's take a second and see. I'm using my eyes. I'm getting really close to see what is happening with the ice there. And what do you wonder about? And Alicia, can you call in some people or read some questions or observations from the chat? What are you noticing with your glasses and the ice in the glasses?
Yes, what are you all noticing? Feel free to raise your hands if you want to talk. We won't see you, we'll just hear you. Or you can type what you're noticing in the chat. Oh, here we have one. Okay, Nicholas, yes. What are you noticing, Nicholas?
The water, the ice in the cup of hot water melted faster than the one in cold water.
That is a great observation. Did you hear that, Naomi?
Yeah, that's great. How could you tell? What did you see that told you that the one in the warm water melted faster?
Exactly when I put them in, like in 2 minutes, it was already melted.
So was it gone?
Oh yeah, it was gone.
Okay, so the ice got smaller, and that's how you could tell that the one in the warm water melted?
Yes.
Cool. Did anyone else notice anything? Or what did some people wonder about this?
We have some people saying that they noticed the ice cube in the warmer water melted faster. Let's see, Miss Trudy's class notices that all of them are melting. They also noticed that the ice cube in the hot water melted faster than the ice cube in the cold water.
Yeah.
One person said they noticed that there is more water in the glass than before.
Interesting.
Yeah.
Okay, so.
Oh, here's a great question too. From someone who's wondering a question, why did it melt?
Ooh.
And I have somebody raising their hand too who would like to ask or make a comment.
Okay.
Okay, John Hammond.
Okay, go ahead and talk.
Yeah.
What did you notice?
I noticed that the ice in the warm water melted faster, but the one in the cold water the longest. And
Great.
that's how I noticed them in the cups.
Yeah, great job noticing. Okay, so now I'm going to revisit my experiment and see what is happening here. So Katie is going to grab the camera and you will see that the ice has gone in both of them. But if you recall from before, the ice in the warm water melted really fast when I first put it in there, and there was still some ice in the cold water. So the ice in the warm water definitely has melted faster. And just to take some more measurements, I have my ruler again. And for the cold water, the height of the water in the glass is at 11.1 centimeters. And then the height in the water of the warm water is at 11.9 centimeters. We will look at these numbers more in a little bit, but I'm just going to take a second to write down the temperatures as well. The warm water temperature has decreased to 100 degrees Fahrenheit. And then the temperature in the cold water is at 62 degrees Fahrenheit. So we will also revisit these numbers in a little bit. And if you have a time to take your measurements, please do so. So here's my board with that. Now, how do you think the ice melting in our glasses is related back to the ice on the Earth? Well, as we kind of said at the beginning, the ice on the plates is like the ice on the plates is like glaciers, the ice in Antarctica and big ice sheets or Greenland, Or in Colorado, we have some ice on the mountains, and the ice in the glasses in the water can be like sea ice, the ice in the Arctic. At the very top of the, well, at this side of the globe, you have this big ocean that from space looks really blue, and there can be ice there covering the whole area. So we're going to take a look at one of the resources that CLEAN has by NASA called the Global Ice Viewer. So if you take a chance later to explore it, it talks about the ice sheets and glaciers, but we're going to look at the Arctic sea ice on the Global Ice Viewer. So if we go there, it'll show you the top of the Earth. That's looking at it like this with Greenland and the big part of sea ice. And if we press play, we can see how the sea ice extent, the area, has changed over time since 1979. So sea ice is ocean water that has frozen because it gets so cold up there in the Arctic. And in the summertime, as it gets warmer, it does melt. But if you, not all the way now, just a bit. If you follow the graph that is showing on the screen, you can see that in the summer it is melting more. So look at how far down that graph goes and how the shape of the ice has changed, that it gets smaller, it has shrunk. So this leads us to our next poll question. So is everyone ready? So as the Arctic sea ice shrinks, as it gets smaller, is there more dark colored material underneath or light colored material underneath? From space. Now think about it from space. We have our from space. Great, so there is more dark ocean, right? So as the climate warms and the sea ice shrinks, it reveals more dark ocean underneath. So the next question is, will melting the sea ice make the sea level rise? Do you think yes or no? Yes, interesting. Wow, a lot of people say yes. There's a few that say no. So guess what? We can find this out. We can look at what our numbers say. That's why we were taking notes. And we can see the change in water level from when the ice melted, right? So we have our glasses here and we have our measurements. So if we look back at the beginning, the water level for the warm water was 11.9 centimeters. And then when the ice was completely gone, it was at 11.9 centimeters. So did the sea level change? Does anyone have an answer? No, it didn't.
We have a couple people.
Oh,
we have
okay.
a couple people.
Oh, great.
John Hammond. What did you notice? Oh, sorry. Try again. John?
The ice. I noticed that the ice on the white plate is melting faster than on the colored plate.
Great. We will look back at the plates in just a moment. But
we have one other person who'd like to share too. Lydia Hunter.
Okay, tell them.
It didn't melt. It melted.
And then did the water go up?
The water didn't go up.
Right, the water didn't go up. So the numbers stayed the same from when we had the ice in it, and then when the ice disappeared, the water level stayed the same. And that's because it was all part of the ocean. So you took the water from the ocean and you froze part of it, but then you melted it. And so it was all just the same thing. It just changed shapes. It went from a liquid to a solid, but then back. But it didn't get anything more. You didn't put more water in the ocean. You just changed the ocean for a little bit. You made it cold and then you made it warm, but it was still all the same ocean. But that does take us back to our plates. So let's take a minute to go get your plates if you have them outside. I've have ours outside, and we can see what's happening there. So if you remember, our plates are like the glaciers in the ocean, or in the on the land, sorry, the glaciers on the land. And we have our dark plate and we have our light plate and we have our glaciers on our plates. Now, take a second. We heard one observation already that someone saw that their white plate was maybe melting faster than the blue plate, or the ice on the plate was melting faster. Has anyone else noticed anything? Does anyone have any comments? Or Alicia, can
We
you
are,
read anything
looks
from
like,
the chat?
yeah, looks like we're still waiting. Oh, I have one person, let's see. Looks like Johannes said that the ice on the blue plate melted faster. And then Rebecca would like to share what she noticed too. Rebecca?
You want to see this is Alma?
This is Alma, and I live in Alaska, and outside the temperature is like almost to freezing. And so, and we noticed that they didn't really change, but they did a
They
little.
melted about the same rate.
Yeah, they melted a little bit. The same.
Yeah.
This
Well,
is great.
we're gonna encourage you to continue to monitor those because you're in a pretty cold area. But I think you should continue to watch those after this is over and see what happens. Okay, let's see. I have someone else here who would like to share. Blakely, what did you notice on your plates, Blakely?
I noticed that the white plate melted faster, but it kind of froze a little bit.
Huh.
This is all
Interesting.
very interesting.
Okay, and then I have John. He would like to share what he noticed.
On my water level, when my ice melted, my water level goes up instead of stayed the same.
Interesting. Did you measure the water level after you put the ice in?
Yeah.
Oh, okay. That is very interesting.
Okay, and then more comments have come into the chat. And let's see, we had someone that said they noticed ice on the blue plate melted faster. Someone said the white colored plate melted faster. And then someone else said the dark plate melted completely and the light melted only a little. And then someone in North Carolina who said it's very hot today, 80 degrees, said both of their ice cubes melted at the same rate.
Wow, interesting. So this is fantastic. We have so many different answers, which tells us that we have a lot more experiments to do. Not today, but in general, that we're all in very different places that have different climates and different temperatures and different humidity levels. And our plates are probably made of different things. Like maybe you have a plastic plate, or I have a ceramic plate, or the shape of the plate might play a role as well. So we will come back to why it is dark and what kind of impact that can have on the ice. But for now, I want to go back to the sea level idea. So I just took the thermometers out, and I'm going to take these plates and I'm going to pour the water into the glasses. But first, we're going to ask you, what do you think is going to happen when I do that? When I take the plate and pour it into the water. And you can also do this at home if you would like, but just make sure the key thing is to measure the height of the water before you pour it in. So as you're melting or as you're answering the poll, I'm going to measure mine. So I'm going to have the glass 1 at time 1 is going to be, it is at 11.1 centimeters. I already have that written down from before, but now we can pour the water from the plate into the glass. But before we do so, I just want to show that I have, my ice has melted much more on the blue plate. So now I'm going to take this and pour it in. Oh, there goes the ice cube. That's okay. And I'm going to take the water from the white plate as well, just so that we have more melted glaciers going into the ocean. And now, as you can see, the water is away from the plates. You can also kind of see that the blue ice or the ice cube on the blue plate is a little bit smaller. I can even put it next to each other. You can see that it's a bit smaller. So now to measure this, and it says 11.5 centimeters. So that tells us that the water level has increased, just as most of you have said on the polling question, that there has been an increase of 0.4 centimeters in this case, and that the sea level has in fact risen when we put our melted glaciers into the ocean. So why do you think that is? Let's ask another open-ended question. Why did the ice melt faster in the water and then when compared to the plates? So why did it take less than 5 minutes for the ice to melt in some of our glasses? And for me, the ice is still on the plate. It hasn't melted entirely, even though it was sitting outside for 20 minutes.
Let's see, it looks like I think maybe John would like to share his answers. So, John, why do you think that the ice melted faster in water than on the plates?
On your plate, on the white plate, on the white plate of your plate, it melted faster. On the blue plate of your plate, it didn't melt faster. But on my plates, they both were stubby and not complete.
Okay. Did your ice, which melted faster, the ice on your plate or the ice in the water?
The cups.
The ice in the
The
cups?
waters.
Okay, the ice in the cups melted faster. Why do you think that is?
Because the warm water of both of those cups, the warm water melted the other ice cube faster, and the ice cube in the cold water goes longer.
Oh,
Yeah,
that's interesting.
definitely.
Okay. All right, let's go to Blakely. I think Blakely also has an answer to this question. Blakely, which did you notice melted faster, the ice in the cups or the ice on the plates? Oh, sorry, Blakely. Trying to get you to, are you able to unmute yourself? There you go.
It melted faster in the cups because in Alaska it's more colder outside, and we have frost in our grass and like almost everywhere, so it's really hard to find sun, so it didn't really melt as good. So it melts better in the cup.
Okay. Great.
These are all great answers. So let's get down to the basics of it. Let's think about back to that first question. What is ice and what is water? So there are three forms. Oh, sorry, I can take this off for now. There are three forms of water, of matter. In this case, we have ice. That is a solid. It's hard. It's one solid piece. And then you have water, which is it's a liquid. It's flowy. It moves. If I poured this glass onto the counter, the water would go everywhere. Whereas if I put the ice there, it's still ice. It's still one solid piece. And then there's gas, which is these little tiny molecules all in the air. So you can think of water in the air as like when you breathe, you can feel that change, right? It's a little bit more humid. One of you said you lived in North Carolina, and it's really humid in North Carolina. So when you go outside, you feel the air is different than inside, and that's because there's water in the air. It's a gas. And so these different materials, these different forms, they have different energy levels. So I'm going to have Katie come up here and help be my assistant. So I'm going to put my mask back on. And when something is a solid, it has a very low energy rate. It's cold. It's all of the molecules are just really tight together, and they don't move. But then when something is a liquid, they might have a little bit more energy, right? So maybe you're just moving your arms a little bit. And as you do that, you might get a little bit warmer. You have a little bit more energy. And then as a gas, you're moving around so much. You're running around. You have so much energy, and you can just go everywhere, right? When you think about air, it just expands, and there's these little molecules just running around. And now if you notice, if you're running around like I am, you're going to tell that you're going to get a little warm because you have so much energy. And what ice needs to melt is energy. It needs energy to break those bonds, right? To turn it from a solid, that really cold, still thing. It needs energy to move, to start melting. And the difference between the air outside versus inside and the being in water is that even though gas moves around so much more, it doesn't really touch the ice. It doesn't give the ice any energy. But water, even though water is not nearly as energetic, it breaks the ice more, because if I'm just moving my arms, I'm making Katie turn into water. Whereas if I was just gas and Katie's really still and I'm moving around, I might poke her once, and then I'm moving around and I might poke her twice. But it just takes longer for that energy to be transferred. It takes it longer for me to give that energy to Katie. So that's why the water has melted the ice quicker. It's because the ice is surrounded by moving molecules that aren't so crazily energetic. Whereas outside, even if it's cold, or even if the temperature is potentially warmer, like I have here, it's 72 degrees inside and 63 degrees outside, I just don't give it. I don't give it away. I don't touch the ice, so it doesn't melt. So that is why, thank you, Katie. That is why the ice has melted quicker inside water, is because the water can transfer the heat faster than the air. So let's go back to the plates now. We're switching gears a little bit now that we've talked about the energy, right? So why, in my case, so I've done this experiment many times now, and the ice on the blue plate has melted faster most times. So that's because it's darker, right? And if we think back to our t-shirt analogy, then that's when you wear dark clothes, you absorb more energy, and then that can go towards melting the ice. So this connects back to the Arctic sea ice. When we noticed that in the Arctic sea ice viewer, as the ice melted, the ocean, there was more ocean. And so if there's more ocean, there's more dark blue. So that is going to melt the ice more, and that's because it's darker and absorbing more energy. This can also be related back to other things that change the color of the ice, such as coal being burned, little particles of black coal. Here in Colorado, we've had a lot of wildfires, and so there's smoke in the air, which can then make the ice darker as well. Now, that just plays an important role. And you can maybe do some other experiments to test how these things change. So we have a list of experiments that you can see, and we would like it to ask yourself what kind of experiments you'd like to do, but we're getting close on time, so you can take some time yourself to make a note or two of what experiments you would like to try. We have a list of experiments we think would be fun. So what happens if you just let the ice melt in your hand? Someone said that it's really cold outside, so is the ice even going to melt in Alaska if you leave it outside, or will it melt if you put it in the fridge? How will the different size ice cubes melt? So you can explore other experiments. There are also other activities that you can do as well. So what happens when you make salt water? How does that affect things? You can go on to the Global Ice Viewer again. You also can check out some of the Serious Science at Home talks. Those are really fun. There's live scientists telling you about things again. So we have 3 of those coming up. You can check this out on our website. And then the last 2 things I wanted to kind of talk about is, well, what did you learn today? Can anyone take a minute to share? We only have time for maybe 1 or 2 people, but I'd like to hear from someone what they have learned through this.
Okay, we have John who's going to share.
So if they melt in the freezer, but if they do melt in the fridge, but in the freezer they don't.
They don't melt in the freezer. Great. Yeah, that's right. It's so cold in there. There's not enough energy to melt the ice in the freezer.
Yeah.
Do we have time for one more?
I think so. Okay, Nicholas.
They didn't do it.
Nicholas, would you like to share?
Yes. When I put the water of the plate into the cups, it raised.
Yeah, exactly. So the melting glaciers are raising the sea level. So the last question we have is also open-ended. So how does climate change, the warming Earth, affect the ice on Earth? And how does the melting ice affect the Earth and the animals and the people? So we have 2 pictures on the slides in case you want some ideas. But I want to hear from you as to what does it mean? So we have the ice melting in the Arctic, we have the sea ice melting in the Arctic, and we have the glacier ice melting all around the world. What does that mean for you?
So waiting on comments, questions. Polar bears live up in the Arctic, and you guys just did an experiment where you noticed that the ice was melting in different circumstances, and these polar bears live on the ice. So how is the warming air going to affect the ice that the polar bears live on?
Do you think the ice is going to melt faster because the ocean is getting warmer?
John, what do you think?
Warm air will melt the ice, but in cold air, it won't melt the ice.
Great. What about the water? What about if the water is getting warm?
It will affect the ice, but if it's cold, that means it won't affect the ice.
Okay. What does that mean for the polar bears?
The polar bears in the cold world and the cold water, they have thick skin that keeps the warmness in the hair, the warm from the hair to keep it for them to be warm in the
But if the ice melts, what happens?
if the ice melts, they get so hot.
Yeah. And their land goes away because their land is ice, and when the ice melts, it's gone. So they have nothing to live on.
Yeah. We have someone else also who said that, yeah, that the polar bears would lose their habitat from the and that the melting glaciers could also flood the seaside cities.
Yes, exactly. Flood the seaside cities. And the photo that's on the PowerPoint is the coast that's been getting eaten by the rising water, where you can see that the houses are really getting close to the edge. And so that can also be a effective climate change. So what can you do? That's how we're going to end this today, is what can you do about the melting ice in the Arctic, melting ice on the land? And you can check out this slide. We have a list of things, but some easy things you can do is just keep the lights off if you don't need the lights on. If you leave the bathroom, make sure the lights are off before you go back in the living room. That's one of the easiest things to do, is just decrease the amount of energy, right? Because the energy is what is melting the ice, the energy. So you want to make sure that you can do little things like that. They'll add up. Also, if it's really cold, put on a sweater and don't turn on the heat yet. Give it an extra hour and then turn on the heat. And last thing is, the last thing on this list to say, you can talk to your friends and family about it and see what the ideas they have, and see what you can do together to help with climate change. So we do have, that is the end of our demonstration today, but if you want to ask a few more questions, we have a few more minutes to answer those, but you don't have to stay. But thank you. This was a lot of fun, and I hope you can go try some new experiments and check on your plates if there's still ice on them.
I just wanted to come in and say thank you all so much for joining us for this. We really appreciate it. I'm the Clean Program Manager, Katie Boyd. Check out cleannet.org and send me an email, katie.boyd@colorado.edu, if you want to reach Naomi or have any other questions about anything you've seen today, and I can definitely help you make some of those connections. And check out our Science at Home series from our larger group that manages CLEAN, the series group at the University of Colorado. And yes, as Naomi said, she can stay. She and I and Alicia can both stay for a few more minutes if anybody has any final questions. Also, to check out, we'll have a recording of this if anyone wants to see it again or take time to look at the different questions. The recording will be made available shortly. Are there any questions or comments or concerns?
Let's see, we just have one person. They wanted to know, they said, great job. And where did you find that great globe?
Katie, where did you find the globe?
I'm actually not sure where they got it. I can ask somebody and try to find out.
I don't know if you all heard that, but Katie said she got it from the Little Shop of Physics, which is part of CSU in Colorado State.
It wasn't like from them. They did a professional development session that I was in, and they provided these. They must have bought them from somewhere, and I'm not sure where.
We don't know,
But we can find out.
but we will find out.
Tell them to send me an email.
Send Katie an email.
Alicia can take it.
Alicia, I don't know if you could hear Katie because she doesn't have the headset on, but you could chat or type her email into the chat.
Oh, yes. Good point. I will do that. Okay, any more questions? Okay, I think that wraps it up.